Hi, welcome to Dr. Pat TV. We're looking at the area between two graphs. Where you could use this in business would be a nice application of if you had the graph of marginal revenue, that's the rate of change of revenue, and marginal cost, the rate of change of cost. If you had those two rate graphs, then the actual area between those two graphs would actually be the change, the total change in your profit. So when the marginal revenue graph's above marginal cost, you would be increasing your profit. That would be a positive change in profit. And if it was the opposite way around, if marginal cost was on top, then it would be losing profit. Okay, so that's kind of like how we could use this. So let's kind of look at the mathematics here. So we're looking at the trying to find the area between two curves. All right, so let's just jump into an example. What I want to do here is I have two functions, y equals x and then y equals negative 2x squared plus 13. One of them, of course, is a parabola that's upside down because of that negative 2 there with the power 2, and then our straight line. And what we're looking for is that area in between. So what would be the process that we need to use in order to find that area? Well, basically, it comes down to four main steps. The first one is you got to identify who's the top function, who's on top, which one's the higher one versus the lower one, because that's how we need to set up the relationship here. There's going to be a subtraction, and so it's top minus bottom, and that's what we need to do is we need to figure out who's on top. So a good graph is a nice way to do it. We've already identified it from our graph that the area that we're looking at for the x squared part, the parabola is on top. Then what we got to do is find the limits of integration. What I mean by that is on the left side of the graph, where does the area start? And that would be the intersection here. And then where does this area end? It would be at the other intersection. So what we're looking for is we've got this area that we want to know. It's just we need to know the left side, which would be the lower limits of integration, and then the right side over here where they cross, that would be the upper limits of integration. And then basically what we need to do is set up the integral. That would be the top minus the bottom, and then we'd actually do the integral and evaluate the puppy. Okay, so let's do that here. So our first step here is we identified who the top function was. It's the upside down parabola. That would be our y2 function. And then our setup is going to be top minus bottom. So that's why I've got it as y2 minus yy, because the parabola is on top and the line is on the bottom. And so we're going to take the difference there. So we're going to take the difference between the top function minus the x there, and that's what you're seeing, that minus x there. Okay, once we do that, the next step was we need to figure out where's those intersections. What are those intersections? Of course, if you're looking for the intersection of two graphs, you set the two functions equal to each other and you solve for x. So basically, we're taking the two functions here, we set them equal to each other, and then we just do some algebra to solve for it. In this particular case, I would bring the x over to the other side by subtracting x, and then because of the power 2, I'd use quadratic formula. And the quadratic formula would give us one of the intersections as negative 2.8. And the second intersection from the quadratic formula was a positive 2.3. And so that would give us the lower limit here, the one on the left, and the upper limit, the one on the right. So I need those intersections. And so I'm going to take these x values and I'm going to put them together, as you can see, in the integral. So what I have here is I have top function minus the bottom function, and then left intersection, the right intersection, and that's the setup of our integral. So we just basically now want to use the same techniques that we've had, the antiderivative, and then the evaluation using that fundamental theorem of calculus, take the antiderivative, then plug these two numbers in and take the difference. And so that's what we do. So we take the antiderivative, in this case it's going to be the power rule, and so as you can see I'm increasing the power by 1, dividing by the new power. And so that's what I've done all the way across the board. I have my limits of integration. I'm now going to plug those two in. So when I plug in a positive 2.3, I get into this function right here, I get 19.144. When I plug in negative 2.8117 into the antiderivative here, I get a negative 25.6. And then, of course, these two negatives here will make a positive, and so we get a total area of 44.83. And so that would be how we would calculate the area in between. And so as you can see, a nice four-step process, determine graphically or other ways, figure out who's the top function, who's the bottom function. Find the intersections so that we know where the starting part of our area is and where the area ends. Those are our limits of integration. Do the antiderivative and then plug in the values and evaluate. So we'll do another example in part 2. Thanks.